Organizations are aiming to develop, deploy, and operate applications in an open hybrid cloud in stable, simple, and secure way. This hybrid strategy includes multi-cloud deployments where workloads might be running on multiple clusters across on-premise data center and multiple clouds. In this demo, we will see how to use Red Hat Validated Pattern for Multicloud GitOps installed on the Cisco Validated Hybrid Cloud Infrastructure solution to manage hybrid multi-cloud application deployments in GitOps way. First, let's understand what GitOps is. GitOps uses Git as a single source of truth used for automated continuous delivery of applications and infrastructure. In the GitOps approach, operation teams manage and update the declarative manifests that correspond to applications in a Git repository. GitOps tools like Argo CD will read the defined manifest and applies the resources to the cluster as defined in the manifest. Whenever there is any change in the Git repo, GitOps tools will pick this change automatically and deploys it to the Kubernetes cluster. This enables tracking changes. Desired state is stored in a way that enforces immutability and retain complete version history. Another big advantage of GitOps is that it is continuously reconciling changes. If someone goes and changes the resources in Kubernetes cluster, GitOps controller doesn't allow it. It always attempts to apply the desired state as defined in the Git repository. Red Hat validated patterns are detailed deployment blueprints, collection of best practices, and configuration guidelines focused on a particular use case. The aim of Red Hat validated patterns is to assist users in efficiently deploying complex applications by providing pre-tested and validated architectures that meet Red Hat's quality standards. The patterns include one or more applications that are based on successfully deployed customer examples. One of the primary benefits of using validated pattern is that Red Hat maintains the configuration across product lifecycles. Red Hat ensures that these cloud-native technologies continue to work together as they evolve, so you can trust that the use case is going to work as intended. With validated patterns, known workloads can be replicated anywhere with easy ways to modify for different use cases. As the technologies you use continue to improve and your use case changes, validated patterns can be automated and updated to suit your needs. One of the validated patterns is for multi-cloud GitOps. This pattern uses OpenShift as a container platform. OpenShift GitOps is the continuous delivery tool for Kubernetes based on Argo CD. Red Hat Advanced Cluster Management for Kubernetes controls clusters and applications from a single console with built-in security policies. HashiCorp Vault is used for secrets management. The pattern is deployed on Cisco Validated Hybrid Cloud Infrastructure solution with Cisco UCS X-Series based Converged infrastructure on-premise. Here, we are highlighting the deployment on FlashStack data center. At a high level, the hybrid cloud infrastructure design in the solution consists of on-premise FlashStack data center, public cloud infrastructure, and a secure network interconnecting the two environments. Control plane and worker nodes in OpenShift on-prem are deployed on UCS X210C compute node. The cloud deployment include Red Hat OpenShift service on AWS, a fully managed turnkey application platform. Two redundant IPsec VPN connections provide secure connectivity between the cloud-native environments. The VPN connections are between two CSR 1000V routers on-prem and transit gateway routers in the public cloud. Portworx Enterprise provides cloud-native storage for applications running in the FlashStack data center and on AWS. Portworx also provides various storage services like backup, DR, monitoring, etc. FlashStack with UCS X-Series supports both IP-based and fiber channel-based storage access. For the IP-based solution, iSCSI configurations on Cisco UCS and Pure Storage FlashArray is utilized to set up the storage access, including boot from SAN configuration for the compute nodes. For the fiber channel designs, Pure FlashArray and UCS X-Series are connected using Cisco MDS switches. Storage access, including the boot from SAN, is provided over the fiber channel network. End-to-end on-premise infrastructure deployment can be performed with Ansible. A repository is created in the UCS Solutions Team GitHub to configure all the components of Converged infrastructure stack. What we also have is we have developed a Kubernetes operator leveraging the existing Ansible playbooks, which helps with easy CI stack deployment. All customers have to do in their hub OpenShift cluster is go to the embedded operator hub and look for UCS CI solutions operator and click on install. Once the installation is complete, it provides a custom resource called UCS CI solutions. Create an instance for it. Creating the instance is made simple. Customers need to provide the basic input for their environment like Intersight org name, prefix for the pools, policies, and profile templates to create, whether you want to configure iSCSI FC, input for pools, policies, etc. Once this configuration is applied, you should see the instance of the CRD in the cluster. You can also verify that the resource is applied properly. While creating the instance, we provided the prefix as operator demo, and we can see that pools are created with that prefixed name in Intersight. The advantage of having an operator for infrastructure automation is running Ansible must be done manually and happens only once. Operators continuously respond to state changes and ensure desired state. This operator is utilizing Ansible and its module library. Customers can use the operator without knowing the Ansible structure or dealing with the workflow. Another advantage is OpenShift users are already using single Kubernetes API to manage everything. So we enable them to use the same established pattern. Once all the clusters are up and validated pattern for Multicloud GitOps is installed, all the clusters can be imported to the Red Hat Advanced Cluster Management for Kubernetes. We can see clusters deployed on VMware, bare metal UCSX compute nodes, and Red Hat OpenShift on AWS. Now to use GitOps approach to manage hybrid multi-cloud deployments with pattern, we need to define different cluster groups in our environment. In this example, we have defined different cluster group for UCS virtualized, UCS bare metal, and one for cloud cluster. After defining the cluster group, configure a value file for that cluster group with all the namespaces to create and applications to deploy in that cluster group. In the example, we are specifying to deploy application called UCS BBQ and Hello World to the cluster group called UCS bare metal. Once these value files are defined, push this to the GitHub repository. The framework makes sure that application gets deployed to all the cluster belonging to that cluster group. We can get all the details of the application components from Argo CD instance of that particular cluster. Now, if I make any change in the Git repository, framework will see that and it takes care of applying that change to all the clusters where application is deployed. Here, we are changing the number of replicas from 3 to 4, and that change can be seen in Argo CD.